this problem number 1 from the review for chapter 7, and problem number 2 are two problems that those problems are application problems, and these are very interesting problems because even though they're very easy to solve, we can see in what kind of problems we're going to be able to apply this kind of functions. Logarithmic functions, exponential functions, those are very important functions in application. So that's why we're going to go through this problem. So these are easy problems. So let's read number 1. It says the function f of x equals to 300 times f of x equals to 300 times 0.5 to the x over 50 models the amount in pounds of a particular radioactive material stored in a concrete vault, where x is a number of years since the material was put into the vault. Find the amount of radioactive material in the vault after 130 years. So they're giving us a function of x that models the amount in pounds of that particular material, and x represents the number of years. So if we want to find the amount of radioactive material in that amount after that many years, so the only thing we have to do is just plug in and change the x by 130 and use the calculator to find the answer. So in other words, what we want to do is find how much is f of 130. So rewrite the expression, but instead of x, we're going to write 130, and then we have this over 50. When you find this with the calculator, let's see, this is going to be 300. Let me clear this. Is 300 times, we open a parenthesis, 0.5 to the power of 130 divided by 50. That's exactly what we have to calculate. Press enter, and it's 49.4815, and it says round to the nearest whole number because we're asking for the amount of pounds in pounds, right? So this is 49 because it's after the 9 you have a 4, so it's 49. So approximately 49 pounds. That will be the answer for this problem. Okay, so problem number 2. This is, and let me erase this, we can go to number 2. It's another word problem. Says the rabbit population in a forest area grows at the rate of 9%. This is problem number 2. The rate is 9%. The growth, the rabbit population in a forest area grows at that rate monthly. If there are 290 rabbits in September, find how many rabbits rounded to the nearest whole number should be expected by next September. In other words, after 12 months. So the function that is given to us is already prepared. Is giving you 290 times 2.7 to the 0.09 t. We don't even have to set up the equation. It's already given. The initial amount is 290. That's why that was placed right there. The 9% is a rate, the growth rate, which is this one. Like I said, everything is ready to go. So we want t, since t is the time in months, we just want to apply t equals 12. So we have 290 times 2.7 to the 0.09 times 12. That's what we want. Again, with the calculator, we're just going to, sometimes, the problems are a little bit more interesting, that we have to graph it, we have to approximate, we have to read information from the graph. In this case, it's just very direct. So it's 290 times 27, we close this one, 27, and we have to the power of 0.09 times 12. Is, I think, oh, I have a mistake, because this is 2.7, it's not 27. Let me do it again. 290 times 2.7 to the power of 0.09 times 12. Is 847.7, but since we are counting how many rabbits, well, is expected to round to the nearest whole number, so it's going to be 848 rabbits. After 12 months, there's going to be 848 rabbits. And that's the answer of the problem.